Okay, short-run behavior, as our book calls it, is kind of the opposite of long-run behavior or end behavior. Long-run behavior is what happens at the extremes, like way off to the right, way off to the left on a graph. Short-run behavior is like intercepts, like what happens in the middle of the graph. So our goal on this is we want to find the horizontal intercepts of this graph. Now, when we hear horizontal intercepts, maybe terminology you're not as comfortable with. If I say x-intercepts, or zeros, or roots, these all mean the same thing as horizontal intercepts. So you may see this other terminology. Basically, we want to get down the basics of x-intercepts always occur when y or f of x equals 0. So I want to plug in 0 to our function, to f of x. Now, as we think about solving this equation down, I like to use factoring whenever possible. To get going on this, we look for a common factor amongst all of our terms. So in this case, I think on the right-hand side, we have something in common. They all have x's. We're going to use the lowest power of x. We can say they all have x squared in common. So if we factor that out, we're going to be left with x to the fourth minus 3x squared plus 2. Okay, that's a good start. All right, look for that greatest common factor. Now, the rest of our factoring, what I think we should be looking for in this case is to split this into two binomials because we have three terms going on. So there's a good chance we can split that into two binomials. Now I get that this is an x to the fourth. We're much more comfortable with our first power being an x squared. But think about how you normally split up that first term. You try to do it evenly amongst these two terms in these two binomials. So that x to the fourth, if I were thinking just evenly, and it's only a 1 out in front, so this isn't a super complicated one. We should be able to split that up as x squared and x squared. Now the number you want to focus on maybe off to the side, I always like to look at that constant, or a times c if it was a more difficult one. But the constant here is just 2, and there's only one way to factor that, 1 and 2. Luckily enough, these add together and make that middle number the 3. So I'm going to use the 1 and the 2 over here. All right, now I need to make sure I get the signs correct so that when I add those two numbers together, the 1 and the 2, I make a negative 3. So I'm going to make them both negative. Negative 1 minus 2 more makes negative 3. Okay, at this point, we want to think, can we factor any more? All right, or should we just start setting factors equal to 0 and try solving down? So in this case, I think we can do a little bit more factoring. Okay, I'm not going to mess with the x squared out in front. That middle set of parentheses, as I wrote it, the x squared minus 1, can factor a little bit further because it's a difference of squares. Okay, if you have a difference of squares, meaning a subtraction in the middle, and then the first term is a perfect square and the second term is a perfect square, you only have two terms, then you can split it up and it works out pretty nicely. So x squared would split up as x and x. The 1 could be a 1 and 1, right? 1 times 1 makes 1. But you're going to make one of these positive and one negative. Now I understand if you look at that last set of parentheses, I'm looking right here, we have an x squared minus 2. And you may be thinking, I only have two terms. Maybe it's a difference of squares also. Now I'll give you it's a difference. And the x squared is definitely a perfect square, but the 2 really isn't a perfect square, right? No two integers multiply together and make 2 where it's the exact same integers. So I'm going to leave it alone for right now. All right, can't factor it further, but I want to figure out when do each one of these terms equal 0. Like what would I have to plug in for x to make this factor equal 0? And that's going to be whenever x equals 0. For this next factor, if I plugged in a negative 1, it would make that factor equal 0. Hopefully you can visualize what I'm talking about. If this whole factor is equal to 0, like if I replace this x with a negative 1, it makes this 0. Since everything's multiplied together, the whole right-hand side would also equal 0 as well. Next factor, if I plugged in a positive 1, there it would make that factor equal 0, therefore the whole thing. But that last one, we can't really do that by just where we're at right now. Instead, what I'm going to do is actually set it equal to 0. And you could do this exact same process with each one of the factors. Just try to speed it up whenever we can. But if I set this equal to 0, I think we should be able to solve this down. We can make it into a power equation by adding the 2 to the other side. And then we can get rid of the square by applying a square root to both sides. Now we do want to include a positive and negative on the right-hand side because we applied a square root to both sides. All right, so right now we actually have 5 different answers. This last one was a negative square root of 2 and a positive square root of 2. All right, so all of these are the solutions for the problem we're trying to answer. And that problem we're trying to answer is where are the x-intercepts or horizontal intercepts for this function. All right, hope this helps out. I get that factoring higher degrees can be a little bit difficult, but start with the greatest common factor if you can find one, and then work with your factoring techniques that we've been talking about. Good luck.